Hello, Algebra. It was requested that I make a few of the videos of the latest material. So I'm going to start with the greatest integer function. It is written as f of x is equal to, and then they have this goofy little symbol here. And basically what the symbol means is that you're going to find the greatest integer that is less than or equal to x. The greatest integer, it's positive and negative whole numbers, less than or equal to x. So given this function, find each value. So the integer that is less than or equal to x, of course, for 7 is 7. 2.3 is 2. Negative 4.8, and you have to think the other way because you're thinking about less than. So negative 5 is actually less than negative 4.8. So once you cross 0, you're actually going the opposite direction in your mind. Negative 5 is less than negative 4.8. All right, and so then because this is the parent function, of course you can have a transformation just like you do any other function. So here we're shifting the whole thing to the right 5. So find each value. You would take 9, subtract 5, which you get 4, and then the greatest integer that is less than or equal to 4 is 4. Now you have 0.5, so you're going to have negative 4.5, and then the integer that is less than or equal to that would be negative 5. Here you have negative 8.1, so you're going to round that to, I'm sorry, you got to subtract 5 first. In my own world, that makes it negative 13.1. So the integer that is less than or equal to that would be negative 14. Okay, so then moving on down here, how would you graph this? The best way to do it is to use, I would start with 0 and then work my way up incrementally. 0, the origin is always a good spot. So here the answer would be 0. And then we said, let's try just 0.25. That would still be 0. 0.5, that would still be 0. 0.75, still 0. You know, you could even do like 0.99, still 0. And that's going all the way up to 1 when it becomes 1. So, and remember when we introduced this in class, we got confused about this, just like with inequalities. This is an open circle, which means does not include. And teaching this year, I've learned this is going to be a good concept to start with next year with my students to make sure they fully understand this in all cases. The closed-in circle means includes, and the open circle means does not include. And I said to one of the students, think about closing a fist. If you grab something, you've closed your fist, right? You're grabbed onto it, it includes it. So it includes 0, 0, and it also includes all of the quantities that would round down to 0, but it does not include 1 until you get to 1, 1. Then it includes 1 and all the quantities between 1 and 2, but not 2. And so it kind of creates this like stair-step effect. So then we talked about domain and range of a function like this. And so we said there are going to be x values for all numbers of x. It doesn't matter rational or integer, there's going to be x values for all numbers, all real numbers. However, the range is a different story. I'm finishing coloring that in. The range is different because if you notice, between here and here, there are no y values. Between here and here, no y values. Between here and here, no y values. No y values, and all the way down. So how do you write a range that includes what looks like all whole numbers? But remember, there's also negative whole numbers. You can't just call them whole numbers because the term only includes 0 to positive infinity. So we call those integers when you have negative numbers, but they're whole numbers and they're negative. So we call those integers. So here for the domain, it's all, oops, go back to my pen, it's all real numbers. But for the range, it's all integers. And apparently there's a notation that looks something like this for all integers. So we're talking about this number, this is the range all the way up. Just, so we say, well, why is this open circle included? Well, because the closed circle to the left of it is the y value. Well, what about the x value? Well, the circle above it is closed, so we include that value. So it's all real numbers for the domain and all integers for the range. Okay, so let's look at, let's see, was this? Yes, there it is. All right. So now we're going to see this basically shift down 5. So again, let's start at the origin. And that origin, the symbol, the greatest integer, means it's still going to be 0, but now we're going to subtract 5 after that. So we actually are starting at -5. And then if we were to do, we'll do just plus 0.25, it's going to be actually, let's see, 25, goes to 0, and then also -5. 0.5 goes to 0, and then to -5. And then 0.75 goes to 0, and then -5. And now how about 1? Well, 1 is 1, minus 5 is -4. And we'll say 1.5 is 1, and then minus 5 is -4. So you can see 2 would be 2, minus 5 is -3. We'll say 2.5 is 2. When you put it in here, it then becomes 2, and then 0.5. And so that's -3, and so on and so forth. So we start at 0, we come down 1, 2, 3, 4, 5, -5, over here, open, over here, open, over here, open. And again, domain, all real numbers, range, all integers. Okay.